Okay, so welcome to part 4 of Kubernetes weekend. So today
Okay.
we just start from where we stopped yesterday. So we just make a recap of what we did yesterday. So yesterday I think we did a lot. So we talk about namespaces, we talk about scheduling, we talk about intent and toleration, we talk about daemon sets. So then we talk about persistent volume, talk about persistent volume claim, talk about volume, how they are being used. So where I would like to start, I will just do a recap of that. Then I start from storage classes, just a little explanation on it. And one essential thing that is important there. So we started with volume. Now I talk about different types of volume we have. Then we talk about, let me clear my screen. This is chaotic. Okay, so we talk about persistent volume. And when we are talking about persistent volume, we have said persistent volume is an API resources that is not namespace based. That is, you create it outside of a namespace and you can use it in any namespace when you want to claim the volume. So now let's check the persistent volume that we have, that we check the one we created yesterday. So we did k get pv. So now for everybody joining us for the first time, you might not know why I'm using k. So k is not the standard command, it is kubectl. So, but then I don't want to keep repeating the same thing over and over again. So I put it in an alias. I create an alias. So in my alias, k is equal to kubectl. That's why I keep on using k every time. Else I will just be writing kubectl. So that's why I see me using k. So now, let's do k gets pv. So this is the default persistent volume we have. Yeah, this is the default one. So this is the one we created yesterday. So this is the one we created yesterday, which is this 3 gig. So we can see that it is bound. So now let's go and check our PVC too. Okay, get PVC. But if we should look at it, you see that we are getting clone PVC, which is bound to this PVC. And this one is pending. This one has not yet been claimed. That's why it's pending. It has not yet been claimed, but we don't see the one we created yesterday. So if you remember, I told you that PVC, we do it inside the namespace. PV is outside the namespace because it's the first administration that we can create a PV. Remember, a Kubernetes application developer doesn't have the privilege to create what? A PV. So it's only the administrator that creates the PV. So the developer inside the cluster will only claim the PV. So now let's get our PVC. I'm not talking about my voters card for those in Nigeria. So I'm talking about persistent volume claim. So K gets PVC in our namespace. I think what's our namespace? Part-3, I think. Yeah. So this is our namespace. You can see this is the PVC we created. It is bonded. This is the PV name. You can see here, this is the PV name. This is capacity. And this is the access mode, which write once. This is storage class. So we created it about 24 hours ago. So yeah, I want to talk about this storage class. So now this storage class, it's now been created in an easy way using operators. So Kubernetes now use something we call operators. So operators is just like, it makes the work more easier. An operator is a very common and essential to when it comes to OpenShift. So you see me talking about OpenShift, talking about Kubernetes. So like I said in my previous class, OpenShift is just a new flavor of a modernized flavor of Kubernetes. OpenShift is owned by Red Hat and it's built on Kubernetes. So operators is very important, and this is used most of the time to create these storage classes when it comes to that. Operator is mainly used. So we can also create our storage class. And what is storage class? So storage class is a way in which you already created the storage. Maybe you created the storage in, let's say, in AWS. And, you know, instead of when we want to create our PV, so you don't need to create a PV here again because we already have a storage class. So when you want to claim it, you just bond it to the storage class. So if you can see here that there is a storage class here, it's because this storage class has been created. So this storage, you can look, if you should look at this, okay, this storage class has been created. We are not the one that created this storage class, it's created along with the Docker. You know, we are using, and we are using the Docker desktop single node cluster. So let me show you that again. Okay, get config. Oh, sorry. Config get contests. So let's get the context. So this is how the context, all the clusters I've created, all these on are hosted on AWS. So yeah, we are using this one. There are 2 node clusters. So this one is what we are using. You can see that the star is there. Then I have another one, Minikube, which I don't have again on my system. Not again. So we have tried that out. So like yesterday, I said we are going to, maybe next week, I will see if I can get enough AWS credits. Then we are going to create a maybe 3 node or 5 node cluster on AWS. So we can be able to do some other things like cluster updates. We'll be able to do snapshots. Then we'll be able to do taint and toleration on it. So we can see maybe in our next section, we now create and deploy, let's say we create our own cluster on AWS, let's say 5 node or 3 node cluster on AWS. So, and we practice everything that we have done again on it, and we see how it is. But that's, let's hope I, get enough credits to use for that. So what am I saying? I'm talking about storage class. So when you create a storage class, you don't really need to run this already. You just insert the storage class in your definition file. That, okay, go to this storage class, then just bound to this storage class. So I think when we create the cluster on AWS, it then will be very easy to create cluster in AWS. So someone was saying in the chat, I have credits in AWS that can, okay, how much credit do you have? Oh, okay. So someone is volunteer to drop his account for us to create it. Okay, that would be fun. So maybe after the class, we can talk regarding this. Then we can create our cluster using AWS. So I think that would be great. Yeah, thank you. Oh, okay, about $500. Okay, we won't exhaust your credit, so we will try and manage it. So I think that's a good development. So be rest assured that in our next section, so we can create an AWS cluster. Then we practice everything that we have said. Nice. So don't miss next section. Okay, so that's about storage class. So today, there is something I forgot to tell us when we are talking about deployments. So it's not that I forgot, it's not that, but I wish I could have talked about it during deployment. So we call it, let me check. Do you have a question? Okay, so that's all about the rolling out and versioning. Now, you know that every time, okay, I think that one will also be lovely in our next section when we are going to be updating our cluster from one version to another. But now, before then, let's just quickly dive back into deployments and talk about rollouts. Rollouts in deployment. So what is rollout? When we're talking about when we want to roll out our deployment, what it means is we want to perform an update on it. And we have types of updates. We have the rollouts, we have the recreate. So what's the difference between the two? So when we're talking about a recreate updates, is when you bring down all your pods, then you create it again. So we know that one. So the disadvantage here is all your pods, what will happen to them is that they will be down. None will be working. Then you can recreate them. So that's the disadvantage. Sorry, I'm talking about just a moment. Okay, sorry. So so I'm talking about the two deployment types. Sorry. So we have the recreate and the rollout. So recreate is the one that will bring down all your pods. So when you bring down all the pods, then you create it again. So disadvantage of it is that your application will definitely be down because all your pods are down. So every container that is running into it, you run inside it is going to what? Is going to be down. Definitely. So rollout is when you do a rollout update, like you do it one after the other. One pod is down, you create it while others are still up. So you do like one at a time. So that one still have a good chance of your application being running because the one that is down will not affect the one that it's not down, that is still up. So now, yeah, I always my sections I said documentation is a very good friend. We always stick close to our documentation, which is kubernetes.io. And if you are writing the CKA, the CKAD, or the CKS, you definitely be you have access to the documentation, so you can open the documentation during the exam and check it out. But trust me, you won't want to do that in the exam because you won't even have the time to check it. So that is it. So okay, now I remember. I think I've said it in two different classes now, but I couldn't remember. So let me just show us a very short way in which you can access your documentation and access your command line, so it's easy and fast. So if you go to kubernetes.io, so just search for kubectl cheats. So if you go to kubectl cheats, so it's going to bring up this. So don't play with this kubectl sheet. It's a very good place for you. So yeah, when you open it, you see different commands that you can easily use. So this one is when you want to source your environment. This place is mainly used when you are writing your CKS because your environment will not be sourced. You have to run this command on your own. But in CKA and CKAD, you don't really need this because it's going to be sourced already. You have the shortcode, this one already in your CKA and CKAD. I don't know, maybe there have been an update, but so far till when I wrote my exam, that was in August. So it's still there. But in CKS, you have to use this command before you can source your environment. So you can see you have, different command in one place. So just like a sheet code, just go ahead to create your object. It's very easy to access. So you have most of the command together. You can easily come here, check the command that you want, quickly use it. That's it. And this one is mainly for imperative way. The last time I talked about imperative declaration and declarative way in which you can declare your command. I said imperative way is just use the command line and you can create it. And the declarative way is when you use your definition file. So that's it I want to show us on this. So let's go back to our command. So now to do a rolling update, there is a command that we use. So k rollout. So if you want to, so there are many, okay, let's do rollout history. It's going to tell us So it's going to tell us history of what we have done. So it's telling us no resources. We didn't put any resources. Let's do deployment. History. What is that? Okay, I think I did. Let me go to off. So now these are the command that we have. So okay, I think I should put one in front. Okay, so we're going to go back to our agenda. Let me quickly explain this for us. So now these are the available commands that we have when it comes to rollout. So for example, I make a deployment and I use maybe Nginx 14.2, just for example, and I update it to maybe 14.6, Nginx 14.6, and the new application that I built, maybe there is an error or something happens with it, or maybe a little error, and I want to bring it back to my previous version. So that is where I will use this rollout. So in that case, it should be ctl rollout undo, then the name of the resources, maybe it's pod or deployment. So now let's go. So okay, so these are all the commands that we have. We can check the history. Here we can pause our updates. We can restart it. Here is resume. We can check the status. We can undo it. So, and here is the command you can see we have it in different. We can use it maybe for deployment, for pod, for replica sets, for replica control, for daemon sets, any of the application resources we can use it for. So you can see this is okay. We can use it. Sorry, these are the application that is valid for, rather not pod. Sorry, that was it. So we can use it for deployment, daemon set, and stateful set. That is what we use what rollout for. And if you remember when I talk about deployment, I said this deployment is what handle your replica set, replica controller, and your pod. And this daemon set, when I talk about it in a previous section, I said daemon set is used to create a replica of an instance in each of the node. So these are the daemon sets. Then we haven't really talked about this stateful sets. We are going to talk about this also. So, but these are the command that we're going to use. So let's check. Let's go back to our command line. Oh, okay, sorry, we're having a command line. So let's do kane rollout status. Then let's check deployments. Oh, that's a typo. Oh, what's deploy? So when we check the status, we can see that deployment, in our first deployment, you could remember, we created one deployment in, I think in second section, which is Nginx deployment 1, and we create another one, Nginx deployment 2. Now let's get deployment. Okay, get deployment. Oh, sorry, why am I? So we have these two deployments. So let's check this deployment here. So k gets deployment, deploy. So these are deployments. K get deployments. Let's get it in a YAML file and see what is there. So this is the deployment. This is the definition file. So now let's do something here. Let's get it in a YAML. Let's redirect it to another file. Let's do it rollout. Let's just name it. So let's just name it rollout. Oh, sorry, rollout.yaml. Then let's open the rollout. Oh, sorry. Rollout.yaml file. So this is template. So let's change the image that we use. Yeah. Okay. So now let's assume we create another deployment with 14.1. Okay, let's do something. So let's change this name of the deployment. So it's going to be a new deployment for us. So let's name this new deployment. Let's just name it Part-4. That's the name of the deployment. And let's change the okay. Let's just remove this label. I wanted to put a namespace before. So let's change the namespace to like Part-4. We don't have Part-4 namespace. So we are going to create that first. Okay. So I think this looks good. So first of all, let's create a namespace called Part-4. Okay, create namespace. Let me just write this in full. Okay, create namespace Part-4. So we have created a namespace Part-4. Okay, get namespace. We have it here, Part-4. So let's create our, what was it called? Our, what was it called? Our deployment now. Okay, create elf this. So okay, get deploy. You can see that it's not there because we didn't specify the namespace. So in the namespace Part-4. So you can see these are deployments. We have 3 replica. So now let's now assume that along the way, there are 2 ways in which you can do this. I can use imperative command now to know what to change the, let's say I want to change the image now. I can do k set image. Let me do set image help. Set image. So this, okay, let me just copy this command. You're going to use this command. So there's something I want to check. I want to check the container name. Spec. Okay, so this is the container name, right? Oh, sorry, I mean Shegun is a container name. So what's the name of the deployment? Part-4. So now this command, now we want to change the image. It's what? Let me check again. Let me check the, what's it called? The one we have as initial. Let me, okay. So we want to change this image to this now. Okay, so it's telling us that we don't have that one. Yes, that is true because we don't specify the namespace. We are doing inside the namespace. Oh, sorry. Container name, which is Shegun. I think we use Shegun as the container name. Okay. So we want to check. Oh, okay. Sorry, I did a mistake. So we want to change. So now this command line is kubectl set image deployment. What's the deployment name? Part-4. Then we'll go to the container, which is the container name. Okay, let's just change to this. It doesn't matter. I want to change it to that one, but that's what don't worry. So this is the container name, which is Shegun. If you should, where do we get the Shegun? When we look at when we get our pod, you see, this is the container, this is the name Shegun. So the container name is Shegun equals to this. Now let's set this image now. We said the image is updated. So let's do get deploy in our Part-4. You can see we have this. Let's check something. You can see this is the image. It's now changed to this. So then let's now go back and do something and change this to maybe 9.9.2. You know it has been updated. So let's get why we can see it's 9.9.2. But the same now, I discover that I make a mistake. It shouldn't be this. I want to roll it back to what? To what is it called? 2.1. So what I will just do is K rollout undo, then deployment. So we can do this, you can either do it like this, deployment Part-4, or do it like the way I want to do it now. So if you should do this, okay, sorry, we are not done. So we didn't specify the namespace. That's why it's telling us deployment Part-4 is not fine because it's checking inside the default namespace. So don't forget that. So now it's telling us that it has been rolled back. So let's go and check to confirm now. You can see it's now in 19.1. Let's check status. It should tell us successfully roll out. Let's check history of what has happened there. So this is telling us the history. So it's telling us like we have the version 1. Version 1 is present. You know, that's the first one we created. You know, version 2, I think we removed it. That's why it's not there. So we have the version 3 because every time we create this deployment, it's creating it at least the first revision. We create another one. This is the second revision. We create another one. This is the third revision and fourth revision. You know, we have created like 4 times now, and we have undo the second one. So that's why you didn't see the second version there. So that's more about this rollout and deploy. Like we are doing what's it called? Updating, then roll it back. Maybe there's a mistake, or we want to pause and continue. So we are going to. So this one too. You know, this one is mostly on applications. Like when we want to do, you know, we are talking. This is more on our applications. I mean, our ports rather. So it's different from updating our node itself. So that would, there are 2 different things. So just have that in mind when we want to like update each. We have what is it called? We have, if we want to do update and installment on our node clusters in different versions. I mean on our clusters rather, sorry. So it's different from this update on our pods. So just note that. So, and I mentioned that there are 2 types. We have the rollout, we have the recreate, which is the rollout is most common. So I want to show something. So if you come to the deployment, I mean what's it called? The documentation. Let's just do rollout. If you want to use the definition file, you can use the definition file. But let me go back on. Can you go back? It's still on deployment. But most of the time, if you don't specify it in the definition file, it always set it automatic. It's always set the automatic to what? To roll out. I think there's a template definition file for that. You can see this is what we did of recent. And another way we can change it in our definition file. Like, for example, when we try to do this, let me go back to the way, okay. We can decide to change it here also in our definition file. If we create another one, it's still the same thing. So you can either do it here or in the definition file, do it as like the imperative method. So if you come here and and you edit the file. Okay, let me do something. Okay, edit deployments. Then part-4 in our namespace part-4. So if you come here and do the same thing, let me change the image to only Nginx. So it's edited. Let's get our our deployments all white. So you can see that this is a new image now. So let's do deployment undo. So you can see it's back to this. So let's do status and check or history. You can see it creates 5, 6 for us again. The 4 has gone. You know, we moved it. The 4 has gone. It's created the 5 and 6 version for us. If you check the status also, you can see it's successfully rolled out. So you can do it in both of the ways. So that's how it works. So now I want to go into another topic called I want to check. Okay, I want to go into environment variables. So that's what I want to target today. So environment variables. So what is environment variable? Why are they useful? Why are they needed? Now, if you bring up your application, you know this is a container. Your application is running inside a container in a pod. Just like when you develop your application on your laptop, on your PC, in your local machine, you always set your environment variable. Why? So that you can able to create an API link, or you can be able to create a connection between what other variables that you are using. So the same principle happens here also in Kubernetes. You have to set your environment variables in which you are using in your container, in your environment. And you have to set this too, because you can't assume the container to know the environment variables you are using, or to know the secrets, maybe your password or username. You have to set it. And also some other configuration that is more important. So this will lead us to 3 topics that we'll be doing now, which is environment variable, which will lead us to Configmaps, and it will lead us to secrets. So both Configmap and secret are 2 ways in which you can set up your environment variables. So we have the Configmap, which is called the configuration, just like you setting up the configuration of your environment. That's Configmap. And the second one, which is a secret, that's where you set your username and password, because you can't just set your username and password there. Note something. The fact that it's a containerized application and it's running inside the pod doesn't mean it's not vulnerable. It can be what? It can be hacked and hijacked. Your container can be hacked and hijacked by someone else outside. So that's why it's very, very essential to be concerned about the security of your cluster, the security of your pod, security of your containers. So that's a specialization of Kubernetes security specialists, because you have to be so much concerned about the security of your cluster, of your containers, of your pod. And another way, one of the way you can do that is that's when we get into networking and security. So we are going to get there. So that's another way where we are doing your ingress and outgress, network policies. So it's very, very essential. So we are going to get there also. So I want us to be fast. So we won't be okay. We won't spend so much time here. So let's talk. So environment variable, I can just search for this and bring it out. Define environment variable for containers. So when you create your pods, we have to create some environment variable in which we'll be using, and tell the container that, okay, this is the variables that whenever you put this, I want you to refer to these variables that we'll be using. So how do we create environment variable? So environment variable is mainly created inside our inside our container. If you can see, this is the container and this environment variable. And how is the environment variable created? Environment variable is created in a key value pair system. You know a key value pair system? So those that are familiar with what is it called? Where object is created is like in a key value. So you have the key, you have the value just like this. We look at this, the container, we have the environment. Then under the environment, we have the name, which is the key. What is the value? So the name, which is the key, then the value, the name like the key, the value, key and value. So you can create your environment variable like this in your definition file, and you apply it. And also at the same time, you can create it in in an imperative way in which you use the command line. So now, whenever you want to create the difference between this environment variable and it's not really a difference, because when you create your config map, you are still going to mount it as an environment variable on your pod. So there are three ways. Okay, don't let me wait. I'll get to config map now. Let me just quickly explain this. So now let's assume this is your pod. You have a container that you create just like the way we create it, and you put the environment variable here, env. You put the name of the environment variable, maybe Postgres database. But that one you can't even use environment variable, because when you're talking about database, it should be used like a secret. So we are still going to want it as an environment variable though, but like something that you want to use as your environment variable, like maybe we want to source the environment, like the way we use source on our command line. So you can use this environment variable too as a source when you source it. So if you want to use it as a config map, you can see this is where you use the environment variable, the key value. You can have as many environment variables as possible. But the thing about this thing is, you can't just be writing environment variable. Like if you have 100 environment variable, for example, you just be putting it inside the container. That might be so stressful. So that is the area where we use the config map. So let me go to config map. So config map. So as I said earlier, config map is used to set configuration for other objects to use. Like I set a configuration and I want other objects to use that configuration that is being set on this pod, on this container, inside this pod on the container. So that's the function of a config map and imports. So now, how do you okay, there are three ways. The first is for you creating your config map. So when you create your config map, then it's two ways. And the second one, you mount it on your on your pod as an environment variable. You create your config map, then you mount it to your pod as an environment variable. We're going to show how we're going to create it now. So just like this. Yeah, this is the config map definition file. You just create something like this, the config map. You can see I told you 4 things are very important: the API version, second, the kind config map, the metadata in which you are going to know everything that is there. And remember in our last section, I told you how you are going to know if you can create this inside a namespace or you don't need to create this inside a namespace. That's 3. Then in config map and secrets is kind of different from other API resources. In other deployment pod and other resources, if you want to create it, you create API version, kind, metadata, and spec. But here in config map, you create what you call data, and in secrets too, you create what you call the data. So data is where we are going to put all the information in key pair. Like this, you see, this is the player initial value, this is the key. The way, key value pair, that's what I'm trying to say. So you put it there. So just like this. So this is how you inject it in a pod. So before we get to creating the pod. So this is just like a template of creating a config map. API version kind, the metadata, what is going to be there, then data, what you want to be inside the config map. So there are 2 ways in which you can use config map on a pod. I mentioned that in our section yesterday. The first one is through volume. When you mount it as a volume, just like we mount our PV as a volume. And it's kind of so just like the way we do for our PVC. Firstly, you create your config map. So when you create your config map, then you now come to inside your pod. You put it here. This is the value from, no, this is for, I will explain it. So this is where you do the volume mount. You can see. So you put the volume mount, the name, maybe config, then the month part, like we did exactly in our PV and PVC yesterday. You put it there, then you remember you're going to set the volume. So the volume name must be the same thing as the volume mount. That's why you see the config here and the config here. Then this is the format in which you use. I'm trying to see if there's something that is, we can quickly create one config map. Now we are going to do it definitely, but I'm just trying to see what you want to use with it. So now this is just a short way. If you want to create your pod, now this is the container. This is for volume mount. If you want to use a volume mount, if you want to mount a configuration, your config map as a volume, then this is how you're going to do it. This is the pod app. This is the pod definition, like the container name. So this is the volume mount. We put it the name of the volume, the mount part, like we did yesterday. This is not really compulsory. Just this is read only. Just send it to true that you just want to read the config map. That's this read only. You only want to read the environment variable. Then again, you set in the volume, which must have the same name with your volume mount. Then config map. So you now name it. This is the config map that we create earlier. So let's just create something like this. So before this, let's create a config map. So what can we use? Okay, let's just use this since it's just a practice. Let's just use something like this to create a config map. Or better still, let me use the imperative method so I will explain that for us. So to create our config map. So to create it with just our command line, which is the most important thing, and that's it. That's the fastest way you can do it in your exam. You can't be going to the file to the definition file and create a config map. So to create a config map, so create config. So you can call it CM. That's the short way. So config map, you name the config map name. Then from, okay, let me use F so to show us how. Anytime you don't even know the command line to use, just use -H. So yeah, you create config map, the name of it, the name of the config map. Then from literal, you put, okay, let me show us there. So you're able to see what I'm saying. Let's just go to the app. Okay. So this is config map. So if you want to create it now, you can create it in 3 ways here. The first one is just to create it and insert your environment variable directly, like kubectl create config map. This is the name, like I said, okay. So this one, I will explain this one now. I said there are 3 ways. So this is the first one I want to explain. kubectl create config map. This is the config map name. Then from letter then equals to the key, then the value that I want to put there. Then second one from lecturer, the key and the value that I want to put there. Do you get? That's the first way. Then the second way is to create it from a file. So instead of me putting all this one key, maybe I want 10 of this, I'll be writing this one 10 times. I just put everything in a file. So in that file, I put it in a key value pair inside that file. So if I want to create that, I will this is the way to create that. I can have as many files as possible. So kubectl config map instead of from literal, it's going to be from file. Then the key one is going to be the path to the file. Yeah. So which is like this, the same way, path to the file. That is the second way. So the third way is using the environment variable. So which is this? When you create it from environment variable. So that is when we have the kubectl create config map. From environment variable, you put the path to that your environment variable, and you can add as many as possible. So let me just use this one to create just a template. So we see how you use it in our pod. Just a demonstration. Okay. So let's just configure, let's just name it 1. Just doesn't matter, just give an example. Let's make it, okay, sorry, this should be 1, then the other one 2. Let's just give it a name just to demonstrate how we use it and how we create it. Then let's give it a config map a name. Let's call it part-4. Part-4. So another thing is it namespace base? Part-4. Let's put it in our namespace. So our config map has been created. Get cm. You see that we don't have any config map here. This is default. Now I told you that. So config map, I told you that is namespace based. You can create in the namespace. So let's check in part-4. That's a mistake. We have this config map that we just created now. And this is the default one, the Kubut created this when we create the namespace. So these are config map now. Our config map is created. So now let's edit. Let's what is in our config map? Let's get get cm. Let's get the template file. Oh, sorry. So let me name it config map part-4 in namespace part-4. Oh, that's a typo error. Okay. So this is the config map name. This is the API version, of course. This is the kind config map. So this is the data that we slot in key 1, you see, key 2. And metadata, this is the part-4. This is the name. So now let's just create a single pod. Now, just a carry on, let's say part-4, carry on part-4, image equals to, let's just use Nginx, or let's use Redux. So okay, but part 4, let's say in a namespace equals to, so namespace is equals to part 4, right? So, but then we don't want to just create a pod like this. We want to put in this environment variable at once. So let's do it a dry one. So don't mind me, I'm using another keypad. So clients in a YAML file. Oh, come on. Okay. Oh, YAML. Let's see, does this look good? Oh, sorry. It's telling us that image is required because we didn't set the image very well, dash image. Okay, run. This is the name. This is the image. This is the namespace. Then when that we run it, this is the template. So now let's redirect it to let's say cm.yaml file. Then let's vi cm.yaml file. So this is it. So now we want to insert our what? Our config map here. So remember I told you we can mount it as our volume. So let's do that. Let's do the one that will mount with volume, or we use environment variable. So if you want to mount it with volume, yeah, let me just copy this like this. Okay, so I come here, my eye. So this looks good. The volume mount can be anything. Let's name it part 4. So this part now, let's change it. So there is a part, I can't remember that part again. I will try and, okay. There's a part that I created. I will just go there now, don't worry. Part 4. If we use this part now, it's going to give us an error. So, okay. So what's the name of our config map that we created? I've forgotten, honestly. We'll remember. I think it's part 4, right? Is it? Anyone? Okay, it's fine. Let's go back and check. Okay, yeah, it's part 4. So I think edit PV. So I want to get the part that we used here. So that's okay. Post parts. Okay, is this just a moment? Oh, sorry. It's okay. Edit PVC in namespace part 3. I want to remember this part. Let me just. Oh, sorry. It's the pod that we put the part there. Sorry. Okay, get pods in part 3. I'm trying to check. Okay, part 3. Okay, because there is a pod we created. There is a part we created for our pods yesterday. Okay, I'm looking for this. Let's just use this part. Okay, this is what I'm looking for. Okay. Months. Okay. So this looks good. I have our namespace. This is volume months. So what's our config map name? I think it's Part-4. We checked it the other time. So now let's create this. Okay, create F CN. So the pod has been created. Okay, get pods in our Part-4 namespace. So you can see it's creating. Let's watch it. Now it's complete. So now let's describe the pod to see. Okay, describe. So if you check, so we are trying, let's describe the pod. Let's see what is there. Oh, sorry, let me do something. Part-4, right? So it's going to describe everything because you didn't specify. So you can see here, so when we describe it, it told us everything about it. So this is where I'm concerned about. Look at the volume. It told us this Part-4. See, there's a config map that is mounted on it. You can see. So that's the way you can mount it as a volume. So the second way is mount it through environment variable. We can quickly run through that also. So if you want to mount it through environment variable, so this is how we are going to mount it. So we put in our env value for no, not this. This volume Configmaps. Okay, so let's go to environment variable. That's not okay. So this is when you want to do it like this. You want to input. Okay, just I don't want to use the previous one. That one might look complicated. Okay, you can use this. Okay, this config map. Type this config map. Let's check. So we can use that, but let me just check if there's still. Okay, so we can just use this. So if you want to use the, what is it called? The environment variable, if you want to use the environment variable, okay, yeah, this is what I'm looking for. So if you want to, so let's go back to our command line and use it from using an environment variable. So let's try and create another. Let's use this same definition file. Let's create another port called part. Let's say part. What can we name? Part-4 new. Let's just call that like that. So now we are not using a volume month. So let's remove the volume month. So we have removed the volume month. So let's paste this here. So environment from, we are using config map. And what's the name of the config map? Part-4. So this Part-4, right? Okay, this looks good. So let's create this file again. So you can see that the config map has been created. Look, let's get our pod. Okay, get pods in our Part-4 namespace. You can see this is the Part-4. This one, that's the deployment we created earlier. So this is the Part-4 new that we created. So now let's describe it and see. Okay, describe pod. This is the name. In the end, Part-4. So you can see it here. Environment variable. Let me check. Oh, sorry. This is okay. Part-4 new. Yes. You're right. That's right. Okay. So let's check the environment variable. Let's save the config map inside the container. So you can see, say environment variable from this. It shows it for us. So that's how to use config map to set the environment variable, both from what? Using a month and using the environment variable. So the same principle also apply for secrets. So now that will lead us to secrets. So let's quickly go to secrets too. Just the same way we did this config map is the same way we do our secrets too. So just one kind of difference. So I don't want us to spend much time today. So I'll quickly rush through this, then go to the next one also, but we'll try and create it. So secret is the object contains small amount of sensitive data. So once you have this, your config map might not necessarily be a sensitive data. It just be your configuration data. But secret is a sensitive, when we are talking about your password, your usernames that must be kept secret. So that's where you use secret. And when you are using secret, the only difference there is it's always in the code 64. I mean, base 64 is always encoded. So if you should look at it, this is the way you mount your secret also. If you want to use volume mount, just like we mount it with config map, this is the volume. The only thing you change here is the secret name, which is the other one. You say the config map name. Now the secret name, that's the only thing you change. And the same way, if you want to use the environment variable, also is that one here. So exactly from environment variable, the other time you use the config map name. So yeah, you just use secret, you just change it. That's like we use the environment from just the way we did for our config map. So the only thing you need to change the environment from, just change the secret ref, change the secret name. So we quickly create this one too now. But I want to show you something that is very important. There are several types of secrets you can create. So let's see get secret. We are going to see the one in default namespace. These are the one that I've created a long time ago. So how do we create secrets? Just the same way from literal, just like we create our config map. But just that in creating secrets, there are 3 types of secrets. Okay, create secrets. Help. So do you see that it's not even giving us secrets? It's not even showing us secrets here. Like it's just showing us the normal command. That is why, because that's where exactly I'm going, because we haven't specified the type of secret that we want. We have a Docker secret, we have generic, and the third one, let me see, kubectl create secrets generic app. Now, if you should look at this, wait a minute. All right. Create secret generic, yeah. Yeah, so what? Okay, let me go to, maybe I think I make. Okay, create secret generic. Yeah, I'm expecting it to show me the help. Okay. The secret name. So let's see. So K creates secrets. Okay, I know what. Okay, I know what. I use secrets instead of secrets. That's the mistake. I was surprised when I saw that. Okay, that's my typo. So now you can see K creates secrets. Okay, so I think before I go to generic, let me do something. K creates secrets. Oh, this is where I want to check. Yeah, that was a typo. So there are 3 types. The first one is Docker registry. So this is create a secret for use for a Docker. If you want to create a secret for a Docker registry, like when you want to pull from Docker registry, I want to create a secret for it, this is the one you use. So this generic is when you want to create it from a local file or from a directory, or you want to slot in your value. So this is the most common one. You create secret. Then the third one is the TLS. That is when you want to create a TLS certificate. That's transport layer certificate, I think. Yeah. So when you want to create that, that's when you use this TLS secret. So this one is majorly used when we are going to create your cluster secrets. So we are going to get to that one maybe in the next section. Yeah. So this one we are using now is generic. So you can see that when I use kubectl create secrets, it's telling me that this one is available. Which one exactly are you telling me to do? So now that will lead us to create secrets, generic help again. Now tell this is the way formatting, just like the way we create our config map. 3 ways is that you create it from file, from a path, from a file, which is from a path, or you create it from literal in which you put in your secret. So let's do something like this. Let's just use this and create one secret now. So let's just name it top secret. Doesn't matter. So kubectl create secret generic. Let's name it part-4. So we are creating this secret in our, in our, what's it called, namespace. Namespace equals to part-4. So our secret is created. Let's get our secrets. In what? Remember, in our namespace, I use the namespace so that to separate each of our sections, so we know what we did in this section, what we did in another section. The other time now I went to part 3, I was able to get the part from what the previous section, so it was kind of easy for me. So that's why I separate it like that. You can see this is the one we just create now. And the type is opaque. So why is it opaque? You are going to see it now. Okay. Edit secrets in part-4, because that's the only secret we have. Excuse me. She's going to edit only one of it for us. Now, why is it opaque? You can see that's what makes it opaque. Why? Because it will encode it in base 64. And no, when you talk about opaque, that means you can't see it. So you can't know, initially I put what? Top secret. So now let me go and decode this now in my command line. Excuse me.
Sorry.
Yeah, thank you. So let me use echo n. Oh, this is where the issue is. I'm using a Swedish keyboard. Where is my pipe? Okay. Yeah. Base 64 encode. I mean, I want to decode it, right? Echo, what happens? Base 64. Oh, why is it not decoding this for me? Okay, let's do something now. And let's put a name in base 64. Let's do something like this. Let's just say Shagun. Then let's pipe it. Oh, where's my pipe? Base 64. You can see this as what? Encoded for me in what? In base 64. If I want to decode this, I will just use this, put it here. Base 64. Then decode. Why is it? Am I using the wrong command? Decode, yeah. Dash dash. Is it? Yeah, it's decode. Am I? Oh no, it's definitely not encode. Or did I spell it wrongly? No? Okay, let me go back to the documentation. Maybe I spelled it wrongly. I might spell it wrongly, but I don't think so. It's normal encoding and decoding. Okay, let me use dash D. I don't think I got the decode wrong. I'm not sure though. Okay, let me just use dash D. Oh, what? Why? Okay. Now this is misbehaving. What did we do wrong? It should decode. It's a normal decode. This is it. Pipe it P64D. Just want to echo it, so it should give it to us. I don't know. Let me check again. So we can just check. If you want to decode and encode, no, I'm not using this. I'm using the command line. Decode. Okay, let's use this. Oh no, I don't want to use this. It's just command. Okay, let's ask. Yeah. I believe we did the wrong thing. Echo this. Yeah, that's what we did. Okay. Okay, no, I think I'm not supposed to use this bracket here. Oh, still the same thing. What happened? So
Double. be equals to at the end of this squeeze.
So it doesn't work with a single one. Yeah, I think, yeah, that's true. Let's see. No. So I don't know why this is not echo. This is this photo. So it works for me. I use it. I don't know. Maybe it's from my command line. Okay, let me try and use something. Let's do something now. Okay. Let me bring in my, yeah. So let's do echo. Dash n this, then we type it, base 64 dash d. Oh, okay. Sorry, it's working. It's here. It's just we are not seeing it. This is it. I was surprised, like it's working there, but it's because it pushes it, we are not seeing it. So let's go. I was surprised at what could have happened. This is it. Every time we did it, it's working. I was, you can see. So when we did it here, this is it.
Okay.
I was expecting to see it on another line and I wasn't seeing it on another line. That's why I was like, what is happening? So it was actually here, but it's because we are not looking. So can you see? Let me copy this again. I'm like surprised at what is happening. Why shouldn't it work? Like if you go here, you see it here.
Super secret. Yeah.
Super secret. And remember that's what we created in our definition file then. Can you remember?
Yeah.
So let's check history. Yeah, I want to edit it again. 601-601. So this is the second one. Let's try and get this. Let's just use the same command. Let's remove this. So it's working, just that we didn't see it. So second one is top secrets, you can see. So that's how we create our secret. So here you put our secret username and password. So when you want to do it, just like I showed us, it's going to be it's going to be like the volume mount, just like we mount it the other time. Like from environment variable, and we do the volume mount, can just do we need to create this again? So we can just create it. Let's try and let's see. View secret .yaml. So let's do this just to create it for us to see. Yeah, we just change this to Part-4. So there's something I didn't mention now. Why are we using this? The reason why we use this command and argument is because we are using BusyBox. If you just create it without this command and argument, this BusyBox will fail. Let's try it. Let's try it. Let me show us. Okay, let me just copy it. Copy. Then dig it. Okay. Let me remove this. Then let's go back here and make it. It's not necessary. Let's just make the container name BusyBox. You see that container is going to fail. Test container. Then let's put it in our namespace so you see. Namespace is what? Part-4, right?
Part-4.
Yeah, I think everything looks good. And we have mounted our secrets from environment variable, right? So now let's create this file. It is created, Abby.
Yeah.
Get ports in our namespace. Part-4. Completed. Wow, it's not a cron job, right? Is it? Port.
But it's not running.
Okay. So now the reason is because restart policy is never. So let's change it to always. So I will explain what happened now. You know, it told us complete, right?
Yeah.
I will explain what happened now. Let me just change this. Then let me replace it. Replace first. F. You're allowed too much. Come out. Restart policy. Should it be always? I can't go. Let me just remove it. So let's go and get it. If not policy, restart policy should always be always. Okay, I know what. Let me do something. Okay, kind. Environment. Image is busy box. I don't want it to complete. I want it to fail. Okay, let me quickly do something. Let me remove the environment variable first and see. But I don't think that should be the issue. I just want it to fail. I don't want it to complete. Okay. Oh no. This is not what I want. So what I'm explaining here is, you know, a Bixby box is like, okay. Let me go back to it. Let me now add the argument and see what's going to happen now. It's going to run. Now if I add this argument, this command. So what we are telling it in this command is to, okay, this one is not even sleep. This one is not even sleep. Like if you put the command for it to sleep, how do you put the command here? Let me just do it like this. Command. Sleep. I think 100. 1000. I think that's it. I'm not sure. Okay, let me check. So you can see now that you are seeing it container creating. Now let's watch. It's running now. So what I command it now is because it is busy box. Its own is just to run and stop. Just like you're running a virtual machine, just like you run this container and it will stop. That's why you are seeing completed here. It has finished the job. It has run and stop. That's why it is completed here. That's the behavior of busy box. But for me to make it run, what did I ask? I asked it to sleep. So once it starts, just sleep. Do you understand? Don't do anything, just sleep. That is the reason why you are seeing it that it is running now, because I told you that sleep for 1000 seconds. In what I did, you can see that it's still running. I told you to sleep for 1000. So once that 1000 seconds is over, it will now tell it completed, just like what it did here.
Okay.
Do you understand? So that is how,
Yeah.
let me check the time. But time is not okay. I think our time is fast spent. Let's just run it up. So that is how we set our environment variable for our secrets. And I hope you're able to, I'm trying to check what I wrote down. Maybe I've covered them all. So I think, do you have any question before we run it off for today? So let me see the question. Which do we
Okay.
use for
The question actually
AWS?
I was this when you're using base 64. I remember when we were working on Audacity that we actually created this thing. I had to convert our stuff to secrets. But that period I was hacked. So is it this generic that we use in creating our password, our secret
Yeah,
then?
so we use generic to create the secret in that scenario. I understand what you're saying. So we use generic, that's why you encode it and you put it inside the template file. So I think we are
Yeah.
using a template file. You have to encode the secret and put it inside the file. So before you now use the file, you now slot it into you now use it inside your pod.
Okay.
So your secret is always your password, your username that you can't show to anybody, or else they're going to hijack it. So that's why we use secrets for that.
Okay. Again.
Yeah, so in the next class, the next section, which is going to be next week, then we'll be using AWS instead of using this single node cluster. So we'll be able to do a lot of stuff with it. Is there any other question?
Not for now.
Okay, so in this note, we stop this section. So, and if you have not liked my YouTube page, it should be kind if you can just subscribe to the channel so you get updates from me and you also help the community to grow.